Simulation Express is a design validation tool that includes a small subset of the features available in the full version of SOLIDWORKS Simulation. Like any other tool, you not only have to learn how to use it, but also when to use it. Before we get started testing a part in SOLIDWORKS, I want to give you a little information about the types of testing you can perform using Simulation Express. Simulation Express is included for free with every seat of SOLIDWORKS, but you should know that there are certain limitations to Express. Limitations you won't run into with the full licenses of SOLIDWORKS Simulation, Simulation Professional, and Simulation Premium. A Simulation Express can be used to perform what is called a linear static study on a part in SOLIDWORKS. One limitation of Express is that it can be used on SOLIDWORKS parts, but not assemblies. You can test assemblies using the full version of SOLIDWORKS Simulation, and with full simulation, you can even determine what kinds of loads a part will experience from its interactions within an assembly. Once you know what these loads are, Express is still a great tool to test and validate the part by itself. Now, I mentioned that Express can perform a linear static study. This term implies three important assumptions about the parts and their behaviors we'll be testing. First, the materials involved must be linear. Second, deformations must be small. And third, loads must be static. If the test you wish to simulate does not meet these criteria, then Simulation Express may not provide accurate, meaningful results. Let's look at these assumptions in a bit more detail. For a material to be considered linear, it must obey Hooke's law. This simply means that a material behaves like a spring. The amount of force applied to a spring is related to its deflection by a constant value. If you triple the force, you also triple the deflection. This describes a simple linear relationship. A material exhibiting this behavior for most of its useful life, such as steel, is said to be a linear material. Most steels and aluminum alloys can be assumed linear in typical applications. Rubber is a common example of a nonlinear material. Nonlinear material behavior is not supported in Express and will not be discussed in this tutorial. The second assumption we make in Simulation Express is that material deformations must be relatively small. So, what exactly does that mean? As a general guideline, it means that the deformation of a model must be small in relation to its overall size. If you can't tell or can just barely tell that a loaded part has deformed, it probably conforms to the small displacement assumption. If the deformation is obvious, the small assumption theory may break down. A symptom of this is unexpected stiffening of the part due to deformation, much as a guitar string gets stiffer as it's stretched. If you're concerned that large deformations might be impacting your results, you may need to explore the response using full SOLIDWORKS simulation. The third assumption we make in Express is that loads must be static. This means that we assume loads do not change over time and that they're applied slowly. Most structural loads can be represented as static loads, including forces and pressures. Time-dependent loads, such as vibration from shaker tables and engines or drop testing, would require dynamic analysis available in the more advanced SOLIDWORKS simulation products. Now, keeping the assumptions I just discussed in mind, let's move on to our first exercise, static loading of a single part.